Hi, myself B.Devananda Rao, working as Associate Professor in the Department of CSC, MLR Institute of Technology, Hyderabad. Today's topic is L attributed SDD and SDD for simple type declaration. Overview of the presentation: L attributed SDD and SDD for simple type declaration. Here, this is the translation scheme. We are given productions and along with productions, semantic rules are given. D representing declaration. D derives TL, that is L dot in is equals to T dot type. D derives TL. T is representing type, L is representing L dot in is equals to T dot type. Then T derives integer, T dot type is integer. T derives real, that is T dot type is real. L derives L1 comma ID, L1 dot in is equals to L dot in. And add type is the function, that is ID dot entry comma L dot in. Another production L derives ID, that is add type ID dot entry comma L dot in. See, in L attributed SDD, the attribute value of the symbol, grammar symbol, is evaluated by using the parent value or from siblings. That too only from left sibling, not from right sibling. See, L dot n is getting attribute value, that is inherited attribute value in. L dot in is inherited value, that is L dot in is T dot type. So T is a left sibling of L, so that L dot in is equals to T dot type. This is inherited attribute. Then T dot type is integer. Here type is synthesized attribute. L attributed SDD using both synthesized attributes and inherited attributes. So that type is synthesized attribute. Type is synthesized attributes and in is inherited attribute. Inherited attribute. So T dot type, T is the parent, int is the children. So T dot type is integer. Then T dot type is real. Then L1 dot in is equals to L dot in. Here L1 is children, L is the parent. Children is getting value from parent. So that inherited attribute. L1 dot in is L dot in. This L1 and L are both symbols are same. Only to distinguish the position, we are using L1. That is L1 is instance of L. So L derives L1 comma ID. L1 dot in is equals to L dot in. And also we are using a function add type. There is a symbol table. In the symbol table, for each identifier entry, we need to add the type. Type we are getting from L dot in. L dot in is T dot type. T dot type is any type, integer, real, float, anything, double. That is added to identifier in the symbol table. Then L derives ID. Add type ID dot entry comma L dot in. Here also, if there is a rule L derives ID, there is a symbol table for ID entry. For that ID entry, L dot in is added, that is type of the identifier is added. Then for example, we will take a type declaration int identifier 1 comma identifier 2 comma identifier 3. Type declaration. For this, first we need to construct parse tree. Derivation always beginning with the start symbol, that is D. D derives TL. Then the first symbol is int. T derives int. Then L derives L1 comma ID. L1 comma ID. L1 and L both are same symbols. I remove L. Then L derives once again L comma ID. Then L derives ID. So if you collect all the leaves, we can get the declaration int ID1 comma ID2 comma ID3. Int ID1 ID2 ID3. Int ID1 comma ID2 comma ID3. Now we have to evaluate the attribute values for the nodes. Then first because this is L attributed SDD, L attributed SDD we can use both synthesized attribute and inherited attribute. Then T dot type, T dot type is, T derives integer, T dot type is integer, T dot type is integer. Then D derives TL, D derives TL, D derives TL. The semantic rule is L dot in is T dot type, L dot in is T dot type. What is T dot type? This is a sibling. L is the, L and T are siblings. For L, T is the left sibling. We are getting value from left sibling. So that is inherited attribute. So that dot N is T dot type. T dot type. What is T dot type? T dot type is int. T dot type is int. So we are getting this L dot N is T dot type. From left sibling we are getting the attribute value. Evaluated attribute value of L is from left sibling. Then L derives L comma ID. L derives L comma ID. That action is L1 dot in is equals to L dot in. This is L1. That is L dot in is parent. L dot in. L dot in integer. L dot in integer. So L dot in is integer comma ID. So for this identifier 3 there is a symbol table. We can add this type integer to the identifier 3 in the symbol table. Next, L derives L comma ID. L derives L comma ID same. First L1 dot in. L1 dot in is L dot in. Parent is integer. So action is add type ID dot entry comma L dot in. Same. We can add type of the identifier in the symbol table. Then so by using this function we can add the type of the identifier in the symbol table. Then identify integer ID1, ID2, ID3. Like that we can get the annotated parts tree. We can construct annotated parts tree for the type declaration integer ID1, ID2, ID3. Thank you.